Hello everybody, welcome to the World of Control channel. I'm Mohammed, and in this video I want to design a neural network model and train it with our data that we stored in the previous video. In the previous video we stored a data u and y as the input and the output of the inverted pendulum model. Uh, As you see, the model was this, and we stored the uh, input and the output of our system in the previous video. So now we need to train our neural network. Actually, first design it and after that train it. First of all, I want to say some information about the neural network models. And in this video, I do not want to talk about the details of the neural network models, the perceptron models, and also MLP models. You can access a lot of information about these models that can actually identify and actually predict anything. They can predict anything, almost anything. And we know that the structure of a neural network model, an MLP neural network model, is like this, that we can see that the model has some neurons and some layers. We have our inputs, our output, the weights of the neurons and the biases. And I do not want to actually enter and talk about the details of the neural network models, but we will use this structure to identify our dynamics. First of all, we need to create a regressor matrix. As we can see in this page here, the regressor matrix is like this, and the y is our output and x is our input, and we have to actually make this matrix, create this regressor matrix to train our neural network model. So first of all, I want to write a function that can get the inputs and the outputs, and after that it can create this regressor matrix for us. So I will go to the MATLAB and write edit to write our function. Okay, function. I will say that the output is u underline modified, and I will name the function as modification because we want to modify our inputs for our neural network model. This function gets the u and u as the input and y as the output, and it gets an order actually. Order here is a value that says that how many steps do we want to see backwards actually. If we, for example, choose the order as, for example, 9, because we want to predict a time series, our neural network model will see or will watch backwards for 9 steps. And the definition of the order is like this. Okay, first of all, we need to know the samples number that is the length of our input. And first of all, we need to pre-allocate some bits or some space to our variables that we want to work with. So I want to say that u1 is zeros of sample numbers and order, and u2 is the zeros of sample number and order actually. And after that we will go to the main loop to make our regressor matrix like this. Okay, we need to say for I equals to 1 to actually order. I will write the end not to forget. And for now I want to first save our model, our function here. So I will save this function as our actually function here. Okay, and now we can see that u1 is actually we want to create this part of the regressor matrix here, and we will say that all of the rows and I is equal to a matrix that has a zeros of I in 1, zeros of I and 1, and the next column we will say that our y has to be here from 1 to sample number minus I. I is actually the number of the columns here, so we can change it as column so we can understand the concept of the code, our code actually. Okay, this simple for loop here will create this part of our regressor matrix. Actually, I forgot to say that we do not need the negative sign here for our outputs, so we do not need it. So because of that I wrote our code like this. The second part, now we want to actually create this part of our regressor matrix. That is u2 is all of the rows, and the first column is the first column of our input. Input is actually u here, and we can enter the main loop for the second part of our regressor matrix. So we can write for column equal to from 2 to the order. Okay, u2 all of the rows and the column is a matrix that actually has the zeros of the column -1 and 1, and the x of actually the first row to the sample -1, sample -1 plus column +1. And so, oh, sorry, we do not need this -1 here. Sample numbers plus column +1. And this for loop here from line 18 to 22 will actually create the second part of our regressor matrix. And here we can create our U modified as a matrix that is U1 and U2 in that. Control S to save the model. And now we want to check our function to see if our function can perform well. Okay. First, I will import our U and Y here so we can have our U and Y. But first of all, I want to make sure that I have our signals that values in our U values now, and Y as well, like this. Y dot signals dot values. Y need to be modified like this because it was a 3-dimensional matrix, so I modified it. Okay, let's check our modification here. U modified. Actually, we can use this command here to see if our function can do well. For the first time, I will choose our order 3 here, and I enter. Okay, what is x? Oh, I think I wrote x here. X is U, our input. Let me check it very quickly to see if there is any problem. Okay, I think it is. Now it is okay. So we can run this. Okay, it has a problem here. It says that index exceeds the number of array elements. Index must not exceed 10,001. Let's see where is the problem. Okay. Zeros column and 1. Let's see what is our problem here. Actually, the U2 has problem. Oh, it has to be minus here. It has to be minus here, and Control S, and now we can run this. As we can see, our U modified is 10,000, is a matrix that has the dimension of 10,001 times 6. Because we choose 3, the order as 3, we see that in this regressor matrix, the first part of our regressor matrix has 3 columns, and the second part has 3 columns as well. So we will have a regressor matrix that has a rows of the number of our samples. That in this example, our sample is 10,001, and it will have the columns of uh, actually 2 times the order of our system, the order that we have chosen for that. Okay, now our function that can modify our input is ready, so we can use it to train our model. Okay, I will open up a blank M file here, and now in this M file I want to write our code that can design our neural network. First, we need to import out our data to the MATLAB, and after that we want to design our neural network and actually train it. So CLC clear close all, and I will save this as train underline underscore nn, and I will save it. First of all, I want to load my data, so I will write u equals load double quotes u dot mat and y equals y dot mat. Run this code to see our input and output is in our workspace, but they are structures, so we need to change them to access the real data. I will write u is equal to u dot signals dot values to access the data of our input, and y is equal to y dot signals dot values again. I will signals oh, it is not signals, it is u here, and it is y here. And if I write u dot u, okay, it has signals now, so we need to write signals dot values, and here we need to write signals dot values, and again I will run the simulation values. Okay, signals. Okay, now we can see that we have our data here. Y has to be modified because it is a three-dimensional matrix here, so we can say y is equal to y all of that to have our input and output to be the same size, 10,001. They are vectors of 10,001 with 10,001 elements here. Okay, we imported our data here. I will write a section named data import. Okay, and now I want to modify our data to be actually the regressor matrix to create the regressor matrix here. So I will say create regressor matrix. And now we can say that u modified u underscore modif is equal to modification, the name of our function that we wrote, modification u and y and order here. Oh my god, order, it has to be order. Okay, and before that I will set an order to be, for example, 10 steps. It means that our neural network will have the data of 10 steps backwards from now in each epoch or in each step. Okay, now we have our modified input that we can apply it to our neural network. In the next video, I want to actually continue this code to design our neural network model and train it with our data. So make sure that you subscribe my channel. I will make a lot of videos like this. Thank you very much.